let us say if we have a linear charge distribution, okay, that is charge is distributed along a line, then in that case, what can we say? We will have to define a term lambda called as the charge per unit length. So lambda is equal to charge divided by unit length. So that is the total charge that would be present on this line. This is the total charge divided by the total length of this line. Now, if the charge is uniformly distributed, okay, then in that case, a small segment of this line will have a small charge dq. Therefore, we can also say that lambda is equal to dq divided by dl. And this particular fact will be used in subsequent problem solving. Lambda is the total charge per unit length, which is also equal to the small charge dq divided by the small length element dl. Similarly, if we have an areal distribution or a surface distribution of charge, then in that case, for a small patch, we'll have a charge dq present on this small patch over here, and the area of the small patch will be dA. So this quantity dq by dA will be called as the sigma, the surface charge density. Lambda is called as the linear charge density, sigma is called as the surface charge density, and sigma will also be equal to the total charge q over the surface divided by the total area. Similarly, if we have a volume in which the charge is present, then in that case, let us say this is the small charge element. This small charge element has a charge dq and the volume in which it is present is dv. So this dq by dv will be a rho, the volume charge density. And this rho will also be equal to the total charge on the total volume divided by the total volume. So essentially speaking, what are we understanding over here? If we have continuous charge distributions, then in that case, we define three quantities. In case of a linear charge distribution, we define a quantity lambda, which is q divided by L. In case of a surface charge distribution, we define a quantity sigma, which is q divided by area, which is also equal to dq by dA. Similarly, lambda is also equal to dq by dl. And in case of a volume charge distribution, we define a quantity rho, which is dq by dv, which is also equal to q divided by v. And thus we understand the parameters associated with a continuous charge distribution.